Okay, so we're finally factoring the right way by decomposition. This is definitely the technique you want whenever there is a coefficient other than 1 on your x squared term. And here's how it works. There's a couple of steps before we really get started, so bear with me for a moment. Our middle coefficient, the coefficient on the x term, is 7. The other thing you have to do is your first coefficient times your last coefficient. I'm just going to go first times third is 2 times 6, 12. So your task is come up with two numbers which add up to 7 and multiply to 12. Now the ways you can make 12 are 1 times 12, 2 times 6, and 3 times 4. You can make these numbers positive or negative, whatever you need. In this case, it doesn't take too long to figure out that positive 3 and positive 4 are the numbers which will add up to 7 and multiply to 12. Now here's what you do with those. We're going to use these two numbers to replace our middle term. So we're keeping 2x squared. Nothing changes with that. We keep the 6. Nothing changes with that. But where the 7x used to be, instead we're going to put plus 3x plus 4x. If you put 4x plus 3x, fine, it's going to work anyway. This method is not going to crash if you put them in the opposite order. Once you have it in this form, you factor by grouping. So we take these two at a time, and we factor the pairs. So 2x squared plus 3x, the only common factor that has is x. Pull an x out and you are left with 2x plus 3. Second pair, 4x plus 6, the common factor is 2. And if you pull that out, you are left with 2x plus 3. Okay, so we've taken something with 3 terms and we've blown it up into this hairball. Do you see why this helped? It helped because we have a common factor here. This is not a coincidence. This will happen every time. This is what decomposition is for, is to produce these common factors. If this did not happen, it's probably your fault. Check your work. You can factor out this 2x plus 3. And with it gone, we're left with x plus 2. And there you go. That is now factored. Let's try it again. 5x squared plus 7x plus 2. So our middle coefficient obviously is 7. Our first times last is 5 times 2 is 10. So we need two numbers which add up to 7, multiply to 10, and it doesn't take too long to see that they're 2 and 5. Just to be complete, the way that you do this, let's say you had a bad moment and you couldn't see that, you have to try to factor 10 as many ways as you can. So you go 10 divided by 1, yeah, that works, it's 10. 10 divided by 2, yep, that gives us 5. 10 divided by 3 gives a decimal, meaning it doesn't go in evenly, so forget that one. 10 divided by 4 is 2.5, skip that. 10 divided by 5, oh wait, we already have 5. So this is now a complete list of all the factors of 10. And then you go through this list. 1 and 10, you could either make 9 or 11, depending how you adjust the signs. 2 and 5, you can either make 3 or 7, depending how you adjust the signs. So I know that's not necessary for little numbers like this, but if these numbers get big and complicated, it's nice to have a system, and that's what the system is. So our rewrite is you keep the 5x squared, and on the tail end you keep the 2, and instead of 7x we put 2x and 5x. If you want to write 5x plus 2x, go right ahead. You'll get the same answer as I do in the end. So when we factor this, the common factor here is x, which leaves us with 5x plus 2. Now, what do we do there? That doesn't look good. 5 and 2 are relatively prime. They have nothing in common. This term has an x and this one doesn't, so there's no help there. The only common factor that these guys have is 1. If you are truly stuck and can't come up with anything else to factor out, then just factor out a 1. And taking out a 1 doesn't do anything. It gives you 5x divided by 1 is 5x, and 2 divided by 1 is 2. But the important thing is we get our common factor. It happened again, and it will happen every time. Pull that out. 5x plus 2. And with the 5x plus 2 is gone, we're left with x plus 1. Factoring complete.